everyone, so it's Coach Fred here, and today we're going to be talking about graphing a quadratic function in standard form. You already have some very important details that you've learned about the graphs, but today we're going to be talking about standard form. To start though, I'd love to recap the three equivalent forms of a quadratic function that we've learned. We've learned about standard form, which is what we're going to talk about today, ax squared plus bx plus c. We've learned about vertex form. So vertex form, y equals a x minus h squared plus k, where hk is your vertex. And then we've also learned about what your book refers to, or a lot of books refer to as intercept form. But if I had my way, I would actually call it x-intercept form. Or even, you might have heard me call it factored form. Well, because by calling it intercept form, you're saying that you're not really specifying which intercept. And we know that graphs can have two different types of intercepts. They can have x-intercepts or x-intercept, but they can also have y-intercepts. So I like to clarify, but that form is y equals a, x minus p, x minus q, where p and q, so p comma 0 and q comma 0 are the x-intercepts. You might see I call it factored form because it really looks like we've factored it. It is in factored form, giving us the factors, therefore the x-intercepts of the graph. But like I said, today's going to be a day where we spend some time on standard form. But to do that, let's just make sure we all understand, and I ask you this all the time, what makes something a quadratic function? Now remember, we have expressions, we have equations, and then we have function equations, or I just usually say functions for short. Now, an expression would not have an equal sign. It could have multiple variables, but it is not something we solve. We simplify expressions. Okay? Equations have one variable, and we do solve them. So if this was a quadratic equation, it might look like this: 2x squared plus 5x minus 7 equals 0. Notice one variable, we do solve equations. But functions have both inputs and outputs, so they're going to have two variables. They're going to have an x and a y, okay? And we don't solve functions. We graph functions, we interpret functions, but we don't solve them. So this is a quadratic function, number one, because the highest exponent of x is a 2. And it's important for you to recognize that because then you can kind of see a picture of what the function is. All right, so let's move on a little bit. Let's talk about, this is the graph of a quadratic function. Now, we've spent time talking about this graph, this parabola, okay? But I want to make sure you've got some of the parts that you need to know. We need to know that this is the vertex, the bottom in this case, so we call that a minimum value. We've got the y-intercept right here. And we can see that it has a nice symmetry point on the other side, or a reflection point, symmetry point or reflection point. We can see that this one has nice 2, we call those the x-intercepts. And obviously there are other points. There's an unlimited number of points on this graph, and I've just given you 2 other points. But hopefully you can see that they have nice symmetry with what? With that line that goes right down the vertex, that mirror. That mirror breaks this into 2 equivalent sides, 2 symmetrical sides. Noticing every point is going to be the same distance away. So that axis of symmetry is going to be in the middle of those points. So we call that the AOS, or the axis of symmetry. It is a vertical line. So it's always going to have an equation of x equals. Now, we could graph this using a table of values. And we're going to talk about that very quickly. All right, so as I said, you can always create a table of values for your function. And that will, help you see the graph. So if I made a table of values for this function, I plugged in values that are in the domain, so -3, -2, -1, 0, 1, 2, and 3. when I plugged those in, these were the outputs I got for y. And you can see that those points might have been on this graph, or they are on this graph. But you might also notice that the last one is 3, 0. So by making a table of values, it is possible that you won't get a whole picture of what the graph is saying. And there are some shortcuts that we can look at to find the graph of a parabola. We can do that by using some of the critical points. Well, over the course of the last couple of weeks, we've looked at x-intercepts, y-intercepts, vertex. So we're going to look at some of the critical things that we should know about a parabola in standard form and see if we can graph it without creating a table of values. All right, so first I want to think about this. Does it open up or down? So remember, when the a is positive, so when a is greater than 0, we know that the graph opens up. Okay? The graph opens up, so it's going to look like a smiley face, a nice U. If a is less than 0, meaning negative, so meaning the coefficient is a in front of that, right? So if it's negative, then it's going to open down. So that helps me immediately get a sense of what my graph is doing. Does it have a minimum or a maximum value? We also know how to find the x-intercepts, and those are points on the graph. So remember, to find the x-intercepts, we set y equal to 0 and then solve the quadratic. Now, you could solve by factoring, the square root method, completing the square, or the quadratic formula. Hopefully, we really would love it if they're factorable. So I'm going to set this equal to 0, and I'm going to solve by factoring. I'm going to try factoring. So I'm looking for the factors of -5 that add to 4. So to me, that looks like x plus 5 and x minus 1, because they multiply to -5, yet they add to a positive 4. Then I'm going to use the zero product property and set each factor equal to 0. So I get x equals -5 and x equals 1. So then I know that the x-intercepts are -5, 0, and 1, 0. Okay, so if I think about that, I'm going to plot those on my graph here. So I've got -5, 0, and what was it, 1, 0? Yeah, and 1, 0. Oops, right here. So I've got that. Now, I know it opens up, so I know it's going to look something like this. So let's think about, where would the x-coordinate of the vertex have to be? Well, hopefully you're saying right in the middle. So it would be, the x-coordinate would be right in the middle, so that appears to be 1, 2, 3, 1, 2, 3, so -2. And let's remember that the middle of points is called the midpoint, and to find the midpoint, we just take the average of those points. We take the average of the points. So if we take -5 and we add it to 1, and we divide that by 2, that will give us the average, which is going to be -4 over 2, which is -2. So that's going to give me the x-coordinate of the vertex. So I know it's going to be at -2, so I could plug that in. So you could use it, find the average of the x's. And then plug in x to find y. Okay, so I'm going to do that really quickly. So I'm going to take -2. So -2 squared, so y equals -2 squared plus 4 times -2 plus 5. Okay, so that's going to give me 4 minus 8 plus 5. So -4 plus 5 gives me 1. Is that right? -4 plus 5, making sure I have it. Oh, it was -5. I knew that didn't sound right. So it's -5. So -4 minus 5 gives me -9. My vertex would be -2, -9. So -4 minus 5 equals -9. So I'll fix that, okay? So I'm going to plot that. Let me go back to that graph here. So -2, -9 would be right about here. Okay, now there are actually a couple more points that you could get on your graph. You could get the y-intercept, right? We know that the y-intercept is always going to be when x is equal to 0. When x is equal to 0, c is going to be our y-intercept. So in this case, -5. So I know I have a y-intercept of 0, -5. So that's going to be right here. And then if I think about that axis of symmetry going right down the vertex, then I know that I'm going to have a point that's 2 away in this direction right here, which would be -4, -5, and that would be my symmetry point. And so I have my nice parabola just like that, using things I do know how to find, the x-intercept, the y-intercept. Now I want to take a step back to that vertex for a second, and we're going to talk more about this tomorrow, but I want you to think about it tonight. Yes, if you have the x-intercepts, you can always find the average of the x's. But there's one part of the quadratic formula we haven't used yet. We've used the discriminant, remember, on the plus or minus b squared minus 4ac. But there's also this x, negative x, x equals negative b, all over 2a. We haven't used this part. And so I'd like you guys to think about how that might relate to finding the vertex. And we're going to talk about that more tomorrow. But that's your video that's it for today, guys. And we are going to talk more about graphing in standard form because I think you're really going to like this method. And I'll see you tomorrow.